All right, guys, can you hear me? Good afternoon. All right, so it's both on the Zoom chat and on the stream, YouTube stream. All right, so I wouldn't be putting up any. Oh, let me change this audio. All right, is it better? Can you guys hear me? Audio? Any audio? No, no, it's fine. It's weird. Okay, great. Just want to know if the audio is good. All right, wonderful. I think it might be a little quiet. Okay, let's see. Yeah, I think it should be fine. All right, great. Okay, so one question came up about coursework 2 exam. It's gonna be in week 10 or 11, depending. So if it's week 10, that means I have to put the notice out now, given that we have our coursework exam next week. So I can still do that. Let me see. If it's week 10, you're right. So that'll be 8th of November, most likely. So it's kind of back to back for you guys, right? It's either 8th or 15th. And after that is group presentation. So I have a kind of play there. I'll see how it goes. Right, so now we're taking this lab online. Unless somebody is in the CSL1, CSL2, we'll see what happens there. Right. Okay, so today what we're looking at, we're gonna I didn't cover all the RIP lecture slides and stuff like that, but hope you guys will read through it. If there's anything, I could always cover it later. If you by request, or maybe record a separate video, because that's a 90-something slide, so I could always do a separate video and put it out. Right, so we download a packet tracer file. Right, and you just open up the usual double click to open. This is the design of it. It's a little different from what we have in the current scheme of things with your switching and all that, but I did this because just to get a different concept out in RIP, because I needed more routers in there. And instead of making it too complicated with your LAN, maybe next few revisions I might add in upgrade the current switching layout and adding more. Right, so what we're looking at is literally connecting about 4 different networks here. So let's label this out here. This is 1, 2, 3, and 4. 4 main ones, right? What's going to happen is that anytime there's a link between routers here, these guys are actually networks as well. Well, it's already considered, right? So that's what's going to add up. So anytime you see a link between a router, that's a network, which means that you have to create a subnet for those create a separate subnet for those links, right? And these are point-to-point right now, so we can use point-to-point configurations. And I think either the OSPF lab is doing that, where we literally go to a /20 slash no not 20 /20 30 a /30 point-to-point link in some cases, because we don't need to use a whole /24 for these two. As a matter of fact, same with IPv6. When you have a lot of IPv6, a lot of network addresses you can put in terms of prefix size, we will bring it down to small. So it'll be like maybe not a /128, it might be a /126, or maybe a 124. Right, so let's just put that in here. So that will be a /30 in IPv4, and in IPv6 will be more like a /126 or something like that we'll use. Right, so ISP and tenant information, this is already set. the IP address I used here is kind of like using UE's IP address, one of the UE's IP address as web servers. So you guys should take a look at that because it's actually based on, I think it's the UE's web server, SDUED. You could just check a look and match it back. Ping the IP and see what you get. DNS server, you Google DNS and you can see the name here. Right, so now we're going to identify your main networks. Now, a lot of you might say, okay, well, when you're planning out and stuff, you might think, well, how I'm going to start with? I'm going to just throw in routers in there. So that's why I always, again, put out this table and start putting it out, right? So you're going to say, and your main networks is based on what your users are, but it's also what your services are. Right, and not only that, you're looking at also what your business requirements are. REQ, right? So when you build main networks, you kind of build out all these things. So you look at your more like the business requirements first. That's the top level. So let me start over the number 1. Then you start to look at your services and kind of come together with your users in one shot, because users and then services, your users and they have a term called stakeholders is another word. Include users are a stakeholder, but you can have more than one stakeholder in a system. Administrator can be a stakeholder, right? Right, a network admin, even a manager, it could be the DBAs, the database administrators, or stakeholders as well in the system, but they're not users. They may be users in another part, but they're more administrators to implement. So all of those things happening. But so what we have is all of these, and when you build it out together, then you start to work out, realize, hey, your network is going to be created. And let me tell you, apply this technique in anywhere you go out there in a working environment. In fact, if you go in a working environment, you can then build out a table and make it look like this. You can ask them, hey, what do you have? And then create this table. Why you would do that is more to get a better understanding of all the different networks. And when you start to, where you could build upon it, you can build firewall rules between them. Firewall rules between these networks to block and stuff like that, or they already exist. So anyhow, so we have marketing, network size 10 hosts. Now, when we do any Cisco stuff, I'm not doing too much of the heavy subnetting. I have slides about it. I have video recordings. So you guys can take a look at it. I'm not focused too much on the heavy subnetting. Maybe you might see it in some of the multiple choice and stuff like that. Yes, correct. Question, coursework 2 is the lab exam. Yes, coursework 2 is the lab exam. It will be in the lab and you will have to use packet tracer. Right, and that's why I have to put the notice dependent timing, because when I'm done with RIP, you will have RIP to do in the coursework exam, because I would have done the lab. And that's when the notice goes out. I put a freeze on what is on that area to learn. Right, so the later the exam, the more content is going to be added on in terms of the announcement. So I'm trying to get this announcement out this week. Right, so 10 hosts, 16 hosts. I'm just putting arbitrary numbers. Typically, IT administration shouldn't be 25. This might be about 10. Small, depending. All these things like marketing and accounting should be maybe up in the 200 realm. It all depends on sizes. Marketing might be about 25 people, 50 people. It all depends on your size and network, right? And how much, and more size and network. It all depends on the size of employees, the users going to be coming out here. The router network. Now, this is kind of like, it's saying 5 hosts, but your router network can vary based on how much connections you're going to have. And in fact, your router network could vary, because it's point to point. This number of hosts is going to change, because it's going to be point to point, means you're going to have a separate network going on and up. Because right now, each of these is a separate network. And I'm putting class B, but I surely go down to even a class, a subnetted class C. Right, so this is the PC IP address details already set. Make life easy for you guys. This is the packet tracer. Right, so remember we defined the IP address network size. Let me just bring up my PDF. That's okay. Right, so this is PDF. Let me go back up here. So your marketing network will 192.168.10, and then you start to set the IPs. Now you could arbitrarily set the IPs 10.2, 10.3, 10.1 is supposed to be a default gateway. Why? Because it's set here, right? And that's why you put that information there. Because you don't want to say, well, why didn't I use 10.1? This is where it is used, right? And your merge marketing router users, look what's happening, not set. So I put this in red because this has to change. The NA not applicable means that we don't have to deal with anything there. This is the default gateway. If we were to put one in marketing router, remember we actually had your IP static route, which is quad 0 quad 0. We're not going to put that. Now there's something called IP default gateway, which you can use too in the command, which we're not going to use. That's more management thing, and we could deal with that afterwards. Right? Again, interfaces, and we're going on the line. Same thing with the accounting, and then we also have IT administration. You'll notice the interfaces for the devices too. So when you're building out your network plan, you could do this. Now, some may say, yeah, well, there's a lot of devices. It depends. When you have a small network, it's easy to build this table out. The cool thing is that when your network expands, it's easy to add more devices. If it's 5 more, it spots 5 more rows. 10 more rows, that's fine. Maybe even 25 rows is still fine. When you're hitting like 100 new devices in your network, then it's going to be more. Now you ask yourself, well, 100 is a lot of work. Question is, why your network expands so big to have 100 devices? That means you have to have budget. That means you have to have personnel come in and administer this thing too. So you should have resources to add those hundreds in there. So starting small is easy. Growing should be budgeted into your growth in terms of updating the table too. So eventually you should not say you're never able to update the table because it's too much devices. Right, and then we have our router IP addresses. These are not set, stated here, not red. And you notice they're matching back, right? So these two were matching back into the previous slide. So if we go back, I'm going to previous slide, I'll just open up a PDF, right? Right, so if you notice the IP addresses routers is here. Unfortunately, I didn't set it here. I put it as not set so that you guys could go on, because I already said not already set, right? So I don't want to do that. So it has there using this information, which is matching up to this. Right. So remember I told you between each router, point to point is actually going to have a network. Well, guess what? Yes, you're going to have to do this. So not set again. So you have some work. So more or less all of this is the routing part of it. So your admins, you're routing, you're doing RIP, you have to configure this. You're the engineer doing this. Right, let me just check something for this. All right, so remember I told you that you have to have, you can't use point to point. So let's go back to the main diagram. Right, so between every single, between each router, it's going to have a link, and each link has have its own subnet, right? Remember, routers block broadcast. So for each broadcast, you must have its own subnet. If you start to have overlapping, and this is a note, and I hope you guys remember to do this. If it's overlapping, I wonder if I could do annotation. Transcript. I don't know this coming. Right, I hope in live transcript comes up so you guys can see it. For your noting, if you, because of this whole or because of these point-to-point links, each link has to be a different subnet from the other. I have cases where students, and especially with more the not the lab exam, but more the group project, where they end up setting the same subnet, or there's an overlapping subnet, where one block of IPs is actually in the same block of, can be in the same block of IP on both links, your routers are going to have problems with dynamic round protocol and say, hey, I'm seeing two in the subnet. It may not allow to put the IP. One router may not allow you to enter the IP. If you do it on one side, while the other side is done correctly, you will end up having router update issues. Your router table is going to not be updated properly. Like I said, you're going to be quote unquote poisoning your routes. You're going to not have the proper information going apart. So just remember that. That's why you have this table. That's why you create a table like this. And that's why I'm asking you to create a table like this in your project. You're going to identify your links between your routers, your networks, and then you're going to work out your networks. Right? Just notice that this is a /24, right? Which means that your fourth octet is where your changes are. Your third octet, 1 to 3, octet 1 to 3 are going to remain the same. The rest of them are going to change. Right? And that is just for one network here. When you go to the second network, look what's happening. Your third octet is now changing. Has changed. Why? Because that is going to define it as the separate network. And you're going to repeat this process. And that's why I started to do this in I did this in /24, so you can get an understanding to create your separate networks. Right, and you notice one thing, I started to do labels by connection. Because a connection can involve more than one device. It can be a connection of 3 devices, and that could end up happening in a group project, and you might see that. Modi 1 course is going to see that, where you actually have 3 devices connected to each of them in the same subnet, and you have to put a switch between them. But regardless of that, you'll have to list it as connections, and then each of them are going to have an IP address associated with each link, and then you can notice the name of the device and the interface. So this is going to plan this out. It's going to help you with getting the right information, because once you have this, it's easy to then put it out into configuration. Right, same thing here, repeat it. Next link, and you can notice the connection again. Right, router introduction. I'm gonna skip this. You guys could read up on this on your own. I'm not gonna set banner message a day, more save time, and then you could save your settings, etc. Right? Sometimes, I told you how we could tell when you were doing switching stuff, how we could tell if you're in the right interface, group of interfaces selected, interface range. Remember, you could set the description on it and then do a view of the description, and you could see where it's set. Right. This is a nice way. Banner message of the day and then banner logging is going to tell you where the banner has been entered. And this is more for you to check out and say, hey, this is the message of the banner I intentionally added this in to say this is the message of the banner. So when you log in and you see MOTD, you're actually going to know, hey, that's the message of the day, and that's where it happens. And your login banner might be in a different place of where you log in. So when you now connect your equipment and your stuff, you're going to get the logging banner. Once you log in, then you might get the message of the day. So you're going to see 2 sets, and that's why I put the label separate. Some people might be tempted to say, hey, you know what, let's forego this, which you can do, and leave it authorized access only. And then you don't know which part of the console you're on. So this is a nice indicator factor to know where you are in context. Right, copy, run, and config. I did this first, then reload so that your settings are saved so you don't lose stuff, right? I used to have an erase here, and that wasn't a good idea because everybody was following it, erase it, reload, and then you lost everything. So I took the erase off. Yeah, there it is. Do not execute in lab. Right? I just put a note here, right? So I just say what to do. Right, normal thing, see if administrative IT clients can connect to clients in the marketing or accounting network. So we're doing the same thing as we did with static routing. So we're going to IT administrative, and this is the packet tracer now. So we hit into the packet tracer. Right, so it's IT administrative. So from PC4, so that's here. Let's bring it up. Actually, you know what? I'll bring up my See, that's why I have multiple documents open. Now I can actually put this here and go to the commands I want. Resize it, make it smaller. It's all shared screen, that's fine. You guys can see this. And because it gives me context, right? Right, so we're going to ping 192.168.10.2. Right, 10.2 now, unfortunately I didn't label it, so you're going to have to use a diagram. 10.2 is supposed to be marketing, but you can scroll up and see. Right, so it's the 10, when I do it's a 10x, that's 10.2. This is marketing. Timeout. Now, if I were to do the simulation mode, and which you could do, you're actually going to see the package is going to stop. It's going to not even reach up to the router. You notice it, right? The link is down. Let's go simulation. Let's check it out. Right? Hold on. Let me just clear. Let's just simple ICMP, and I'm going to see error protocol. Right. Right. So it's literally erroring out. Getting times out. It's not even reaching. You notice the link here is down. So it's not even reaching out. So we need to fix that. We're going to do that just now. The same thing from PC5. You'll notice it has the same thing. Doesn't matter where I ping, I'm going to get that same error, right? When you look at your design and you look at your diagram, there's no gateway enabled. The interface of the gateway is down. So that's not going to go out. So no matter if I try any of these, it's not going to work. Right now, you'll notice that other part of the diagram showing you ping this. These are the default gateways that you're pinging. So this is part of the diagnostics. I try to ping the PC on the other side. It's not working. I say, okay, let me try pinging my default gateway. Right, and it's not working. And you'll notice some other steps here. From try pinging router 1 IP address. Then try pinging router 2 IP address. And you can notice that it's not going to work, right? 10.1. It's not going to work. It's not going to get out. So we have to continue, right? So we'll be configuring the IP addresses and all relevant interfaces. We're going to use the user's router. Right? So we'll go back to this diagram here. Let's see it. Right, so it's a user's router, and this side is where we're looking at. Right, so we're going to configure on this one. So you may say, well, why am I pinging configuring the left side to right? Well, that's based on it. You can actually change it the other way. You can go from the IT side and ping and then go out. But I'm going to do it from the user's router. And as you go along, we configure all interfaces that's directly connected. Ask yourself, well, why you're doing that is one, you don't want to be jumping around to different devices, especially if users might be in a remote site. So you plan it out in advance. That's what we did. We plan it out. We have all the information we need for this. Right, set up marketing gateway, and we go in there. So we're going to do, I'm going straight into the user's router. show IP interface brief. Right, you'll notice there's no IP address assigned. So eventually we're going to have interfaces assigned with IP addresses. That's what we look at, right? Configure terminal. We're going to select the interface. Now you ask yourself, okay, well, which interface? Remember, you planned this out before, right? I hope you guys did that or understand what we're doing here, right? So let me go back to my PDF, right? Not set, right? But what we're looking at, these here. There's users to marketing. There it is. You can see it there. Oh no, sorry, this is in between. That's this one here. That's this one. To marketing network users. And that's what's happening here. Then you have your, there it is, interface here. So you plan that out. You don't come and randomly say, oh, well, I'm going to pick this interface and do it. You plan this out. Zero one, oops. Right? So you can always easily make a mistake. IP address 192.168.10.1. Alright, do a shut. Right, no shutdown. I could do an exit twice. I think I'm supposed to do a do show IP. Right, I didn't show it yet. I'm gonna set it up now. Hold on. Right, there it is. It's up and running, up, right? So now we set up on the accountant gateway. So we're going to do next one, accountant. Right, we did show IP interface. We're going straight ahead, right? Interface gig 0/2. IP address 192.168.20.1. 580. Shutdown, no shut. And right. We did show IP interface brief. Now it's up and running. So this is what I want you guys when your group project, when you're going along and you're making any changes, each time you set an IP, do a check. Right? So you may have all the commands there and you copy paste it and it run and just do a check and see, right? As a matter of fact, your checks can actually be part of your when you copy paste. Just come back now and show you. Right, this is IP address on interface to intermediate 01 link. Let's see who that is. Right, so we look at this. It's up and green. They're down. Now it is up. So what happened is that this configuration was done when it was literally nothing was on the interface. The interface was shut down. That's what the routers. Switches, when they come out of the box, the switch interfaces are always on. All right, out of the box, you can plug in and it'll work. But in the case of the routers, now it's off. So we're going to deal with intermediate 01 and then intermediate 02. Makes life easy. Look at that. We didn't have to move and click around somewhere else. Big 0/0. And now we get into the 172 IP address block realm. 1.1. We do a shut, no shut. Just to reset, kind of reset the interface, especially on the other side. And to IP. Right, so the next one is there. Just a deviating a bit. I was just going to do a show IP route. I told you how routers are set up with when an interface is you set an IP address in interface and it's in an up state, right? So that's just one. But this is the interesting thing about it. I have set 3 IP addresses on the interfaces right now, right? When I did the show IP route, I'm seeing only 2 what you call connected. One here, the 10 and the 20. So the question is, why am I not seeing the 172? Even though I mean status is up, but look what's happening here. My protocol is down. So even though my status is up, which means status is here, layer 1 physical, your protocol is down, and you ask yourself, well, is it because of the router is the problem? Protocol is down because layer 2 is down, therefore layer 3 is not going to be there. It's set, but it's down. And because of that, it's not going to add it onto the routing table. So look what's happening here. Once this protocol is down, it's not added to the routing table. Go back to the look and see why. So you have to do some troubleshooting. But a simple answer right here. Protocol is down because your interface, the intermediate 01 interface, is not active. So even if I do the shut no shut on the user side, it's not, the link is not going to come up. It's going to still say down. Right, so this is where you have to now know that you did all the work on the user side, right? And now you have to go on and do work on the other side, right? So that's why you pre-plan all of this. If you don't, you're going to end up wasting time going back and forth on sites trying to solve it. If only you alone, then you have a lot of time you're going to be wasting. It's just, if you have somebody else on your site, you could call them and sort it out. Right, so the intermediate 01, and then we're going to deal with the intermediate 02, right? So that's the one in the lower right. We just show you this, right? So that's what this is, right? So we did all these links here, these 2 links on here, and then we did this link above here, and now we're going to do the IP address config there. Configure terminal, interface, gig. Right, we do a shut, no shut. This is more to see. And look what happened there. If they still changed it down. So let's do an end and show IP in brief. Right, so this, and look at this. This is even weird. The physical layer is down too. Right, so this one is up, but your line is up, but the protocol is down. Now this one is saying the line is down and the protocol is down. And we just did, remember, we just did a shutdown, no shutdown. It's supposed to come up. Right, so you ask yourself, well, why, what's going on happening here, right? Just to let you know, you'll notice a few things. One, the interface name is a gig 000, but that is not the thing. If you drill down into the router, let me get to the packet tracer. You'll notice the link is a different color one. It's a red link, but we're not looking at that. Not just so, what we're looking at is, see, all these things are layer-ish. Look at it, layer 1 supposed to be their physical interface, and then layer 2 with the MAC addresses and stuff. But who's this? Gig 00, right? So we have to actually go on equipment itself. When you do on gig 00, nothing here is telling me what it is about. And I did a shut, no shut, right? Let me make sure I am. Yeah, that's it, 000. So this is it. We're doing it here. Right? It's only when we go into physical and we look at the interfaces, you're going to notice a few things. There's some interfaces that are not the regular. You have the Ethernet that you're seeing here. Look at the ports on the switch, on the router. Can I zoom into this thing here? A few things here. You'll notice that the typical ports we use is Ethernet, which we know. Some is console, or we use the connect to configure. This is the management port to manage it remotely, SSH and stuff. could use these, but more or less this one. This here, this next WIC port, one port. What I placed in here, this is what they call an SFP. Let me just see if I can get it. Not this one. All right, there it is. Okay, so let's come back up. Yeah, right. That's what this is. This is a single wide HWIC with one small form factor pluggable SFP, they call it, slot. Can be popular with Cisco copper and optical gigabit Ethernet SFPs to provide one port gigabit Ethernet connectivity on all Cisco integrated service routers, but that's not the thing. It's copper or optical. So this is the thing. They have a term, we call it electrical ports, and we have something called optical ports. Electrical is copper. We could say copper for now until a good years, until they change out the line, the cabling, and type to like a mix of aluminum, steel, kind of bad quality crap for data. So right now for data transfer, if it's electrical, it's copper. Anything else is going to be cheap and break like aluminum, or if it's more like gold, it'll be more expensive, of course. If we get a better metal that can be used to replace copper, that's cheap, right? So it'll always be copper. And when they call about, somebody asks about when they say UTP, so UTP, copper, electrical, all kind of mean the same thing at this point. Electrical is because you're putting electrical signals, while optical is either infrared lights or laser. So with the case of this situation with this device, give me the two. I'm here. Let's do it in here. I'm just gonna put out some stuff, right? Right, on the other side, this is down. We're gonna fix this up just now, right? But that's not the point. The point is, if we come back to this router, we do a show, faces gig, right? Both at the same time. Right, even though it says line disable, it's supposed to be no shot. We would have brought it up. This way, this should have been fiber. I don't know why it's doing this. Let's make sure it's right one. Yeah, gig 00. It's bugging out. It's not supposed to show me media type is RJ45. That could be bug. It's supposed to be something else. All right, let's move on, and as we fix it, you'll see it come back up. Right, so we just did all three. And if you do a show IP in brief, which we just did, right, all interfaces are set up, so we can actually move along to the next device. So let's move on. Right, so see clients and marketing, connected clients in the accounting, so we can do a ping. And we could ping from there and see how it goes, right? So what we're looking at, it's packet tracer. So we're going to see if marketing can communicate with an accountant, right? Now, because of the static routing labs that we've done before, yes, these are supposed to work, but we're going to test it, right? Just like your exam, just like your group project, sorry. We're going to see, right? So what we're going to do, we're going to open a device on one of these. So PC0. And we're going to ping 168.28.2. I ask myself, okay, why are we doing this? We have our table, right? Set up it up. 20.2, who's that? 20.2, we're down there, right? So we are PC0 is marketing, and 22.2 is this, right? So that's why you did your table. Look at that. We're getting a response. We're good. Right now, the same from PC2. We're going to ping PC0. We're going to repeat that. All right, spares PC2. You count it. and you get a response immediately. Marker just learning, right? That's what's happening there. So packet is flowing between this router users. Like I said, once you put the interface IPs, it's going to do what it does. It's going to route, especially with the up state. And then when we do the show IP route command, it's still again only 2, but it's there. 10 and 20 is there, so it's doing what it has to do. Right. So now we're looking at the IT router configuration on all route relevant. So we're going on the right hand side now. Ask yourself, well, why? It all depends. Arbitrarily, maybe you could say the distance to go between them, maybe IT routers along the way. So IT routers up here. So we're doing the upper right hand side. All right, upper right hand, and we're going to do this. All right, that IP address is set. 0 and all /24. We do a shut. No shut. I'll bring it up. We do an end. Try to keep this brief to see what we're doing is correct. Okay, IP is set and it's an up state. One way, it is a nice way to tell your IP is there properly. You could end up making a mistake as well, right? Right, so now we're also going to set up the interface to intermediate 01. So with IT, you're going to go from right to left. That's what we're doing. .168.1.6.4.2. Right, do a shut, just to do a reset. And that's why you do the shut, no shut, just to say, hey, you did it. And you want to make sure it's done right. IP interface brief, there it is, it's set. Port 2, but look at it, this guy is in a down state. What is an up state, right? So there's a few things. One, it can be electrical or copper. Down protocol down could be the other side might be down, right? While as opposed to the other one is an up. Why is it in an up state? Because it is a switch on the other side, which is always active, right? So we just did this. Right, now we're going to set up the intermediate 02. Based on this design, it's the router going down, and then there's one to the ISP. And then we'll finish with the IT configuration, right? Right, shut, no shut. May or may not have to do shut, no shut, but I'll tell you why. In the event that the port is already shut down, you'll want to do that to make sure it comes back up, right? Should I interface brief? Oops. Right, who does 5.1? Right, down. So even though we shut, no shut, so there's a high chance it could be a fiber interface. Based on the packet tracer, it's red. This in this example is red. It's high chance it's fiber. Gig 00, right? So we're gonna deal with that. So we did here, right? Clock anti-clockwise manner, and then we're gonna go to ISP. Let's check it. ISP link, right? So a few things is based on design, right? So that's why we set this IP. We get met 0/2. Configure terminal, right? Oh, we're already sorry. We already invalid hex value. Oops. Already did an interface, right? So we're going to set the IP address 181.188.31.66. Now this is an IP address that was used by an actual ISP. I'm not so sure if it's Flow or something, but it's an actual IP address. So if you go online and do IP info check on this IP block, it'll be that. Again, this is your network. You can use whatever private public IPs in there as packet tracer. It's not going to go out the internet. Just to note, your home routers that you have, chances are you can't really set these IPs, right? Because the ISP is going to give you a certain it's going to be dynamically set. But if you're doing with a company and you're doing with static IPs, the company is going to give you the company is actually going to give you an IP block, a /29 in some cases, and then you actually have to set the IP on that interface. And this is in this example here. All right, do a shut. No shutdown. All right, set up, which is good. This one you want to make sure it's good. It's as in the one going to the ISP. All right. Main reason is because this is what they configure for you. And if it's not working and you did what you need to do, you have to call them and tell them, hey, something's not broken, right? Right, show IP interface brief. Now, based on this table, status protocol, make a guess on which interfaces will be in the routing table, which of these IP blocks. Once you see the two are up, we're working on that. Status and protocol are up, there's a high chance it will be there, right? So you notice two of them are down, the other two are up. So we're going to see two sets of IPs. And there it is here, right? One to your main local network and one to the ISP. Once we start to touch the intermediates, then we're really going to see things coming back, lighten up. All right, so now we'll be configuring the intermediate address. Sorry, let's go back. Yeah, let's get back to my. All right, put is intermediate 01. Right, as this side here. Now, readily enough, not readily enough, which is cool. We already did users, we did IT. The moment intermediate is configured, you're going to have links coming up on both sides. Right? When I mean link, this linker, this is let's say layer 3 link routing is not done yet. We're going to work on that. Intermediate router, let's get there. All right, so I will be speaking less and typing more. Because it's the same thing here, right? Big 0. All right, just double check, make sure it's the right one, correct router name, and that's why you sometimes name it properly, right? I think the users wasn't named, but you gotta be careful, right? Shut. Cool thing about doing the shut, no shut one time, you could actually see what's happening here. You see two things, line and then protocol. It means that you're going to have some routing table stuff in there, right? Right, up state, which is good. If you do a show IP route, there it is, going to be entered in here. Right, now this route has 3 interfaces connected to it, so there's going to be 3 IP addresses we're going to set. Intermediate router setting up interface to IT link, so that's left to right, so we just did top to down. Now we're going to do left to right. Shut, now shut, up, nice, we're getting it there. Always good to see that that up state. All right, we're good. 0, 1. And if you do a show IP route table is going uppity directly connected, we're good. Next one. All right, so this one is the intermediate 0, 1 to intermediate 0, 2. So that's a diagonal link here. Well, what I didn't do, I didn't circle it in this diagram, but I really hope you guys get the picture right. King 0, 2. IP address 172.1.6.3.1. All right. Shut down. No shutdown. Right. So notice there's only one up state. There's not there's it didn't get another up message, which means something here. If you do a show IP interpret brief. And that's the thing, when you're doing testing and stuff and you see only one state up, but you're not seeing the protocol up. All right, and you might, depending on what you're doing, you might have to start to worry, right? But once you know that you didn't finish on the other side, remember we didn't touch intermediate 2 yet, we know, hey, there's a chance it may not been configured. And that's why it's still in the down state. So if you do a show IP route, you're going to still only see 2, right? Only 2 routes connected here. Right now we did 3 configurations. We finished intermediate 0, 1. Finish with 2, right? So now we're going to deal with intermediate 0, 2. So we asked ourselves, well, look at this guy. He's in between. He's not doing anything. What is the point of having him there? Right, we're going to demonstrate redundancy and what happens when we start to fail. So if intermediate 0, 1 breaks down, intermediate 0, 2 handles the traffic flow. All right, and that is what the internet basically is built up on. RIP is not the protocol, but that's what it is. That's what the internet has, links like these. As a matter of fact, this is where the group projects are going to rely on you doing this, because when one site fails or one link router breaks, the rest of the network still works, right? That is how it's supposed to be. So you kind of build in a mini internet. For those who are doing the heavy spanning through the switches and layer 3 stuff, that's actually going to be that's actually going to be showing you how you build out your network in an internal, like a campus network, where you're going to have layer 3 switches kind of help do the routing for you, and you could keep adding and removing. And if some equipment breaks, your network still functions somewhere. Your rest of network still functions, or a link breaks, it still functions, right? That is the purpose of doing it. We're not relying on only spanning through things to do the work for you. You want the span through to do the work, but you want the routing to help as well. So you have to change things. Right. So let's continue. Intermediate 0, 2. It's this guy. Back to PowerPoint. The users link, right? So it's seeing the intermediate 0 to users. And as we go along clockwise, things are gonna start to come up, right? You notice the red links here, these are the fibers. And once you start to enable them, you're gonna see links coming up. Sure, IP interface brief, so you'll notice nothing set, right? We're going ahead. Right, first fiber link, IP address. Right, do a shut, no shut. Right. Notice your two messages here. Your link is up. Your line protocol is up, right? So IP read, and there it is, up state. That's a fiber link. And if you do a show IP route, right there it is in link accept. On to the next one. Intermediate to IT link. All right, that's the one from down up. And that's what, a fiber as well? Yeah, man, fiber as well. All right, both are coming up, which is good. Right, up states, which means that our show IP route will show both of them in the table, right? It's there. And on to the third one now. Right, between it's 02 and 01, and that's just a regular electrical or copper link or UDP. Shutdown, no shutdown. Right. Line is up, protocol is up, which is good, right? Show IP interface brief. Show IP route. Three of them all up. We're going to get three interfaces here. And yeah, we're looking good. All green. This is what we want to see. So when you're starting up your configuration, guys, with your group projects, well, GNS3 is not going to really help you with that. It may or may not depend on the link. It might be up, but it might be configured. But the point is, you're going to get these up, and you're going to get your routing table populated with these directly connected routes. Remember, we have not touched static. Main thing is we get directly connected. So the cool thing is, because you're directly connected, we have this. This is where your dynamic run protocol is going to use this information to then help with sending out updates, right? So it's going to say, hey, I know all these directly connected routes. I'm going to send updates to the other links about these networks to other people, right? So that's how it's going to do it. And you notice you only need to know this. When that's update sent to another router, so who are we using intermediate to, is going to send updates to IT and users. IT is going to learn about not just the user's network, but whoever is on the other side that IT not seeing. These are the links there, right? That is where the dynamic route protocol comes in. Right, so just summarizing, because we are hopefully online and you guys are home, I'm not going to take a break. I'll leave you to get up and take your break whenever. You could always play back your YouTube video, right? And play back what I missed, right? What you missed. All right, so that's the advantage of YouTube. Because rewind and double speed up, right? So what we're going to do, summary, all relevant interface should have their IP addresses configured, which is what we did. You can ping the IP address on the neighboring router. So this one, let's do that, right? This is for your group project. Now, I didn't do it here, but we should. And you ask yourself, let's get there and let's see who, right? So let me just get this raised up there. And you ask yourself, well, where are these IP addresses? How can I find them? And where you build your plan already, right? Intermediate 02. So we're looking at intermediate 02 to users. So we're going to ping 172.16.2.1. Right, we're getting it working here. MAC address stuff, that's what the first timeout is. Right.
when you're configuring your IP addresses on your interfaces, make sure you could ping the IP on the other side. So I'm pinging the users. So I'm intermediate 01 as well. And who else? No, 02. Who else is connected to me? Intermediate 01. Right? What's his IP? 3.1. And that's the next reason why I did not do a variable length subnet mask here, because then it'll be very complicated to set up. You're going to see that in the OSPF though. At least in the RIP will make it easier. Let's ping on the other side. Good. We've got two IPs there set up. Who's the next one that deals with intermediate 02? IT, right? 5.1. 172.16, 5.1. Ping that. On an interesting thing to know, if you know deal with GNS3 and stuff, or even with packages with Mac, you notice that when you start to see the first time out, and then it works, that technically means you're really communicating with the other side in most cases, right? Because it didn't really mark on the other side, it has a setup. Now, if it ping and it went immediate, two things means. One, it's a local interface you're pinging. So let's say it's 1, but it's 2, right? You see there's no MAC address stuff here. I mean, it learned the MAC already. But if it happened already immediately, there's a chance that it learned the MAC address already, or it's in your own interface that it already knows the MAC address. It didn't have to send out a broadcast or ARP. Right, so that's one little diagnostics you could see how it's happening. So we did intermediate 2. I'm going to quote unquote assume others are working. So when you guys are configuring your routers and you're setting the IPs, and that's why you plan it ahead, you start to ping and make sure you can get your interfaces pinging out, right? And the good thing is that as you go along, and let me go to the diagram there, as you configure users, and I did a ping, I could only ping my PCs and done. I couldn't go intermediate 01, that's fine. As you do intermediate 1, and you ping back, it's supposed to ping back users. You might get the IT, but ping back users. And then you go on back to IT and you do the same thing, and you do that manner. So intermediate 2 is pinging these guys as all these 3 interfaces connected is working. If I go to intermediate 1, there's a high chance it will work. At least 2, intermediate 2. I know this link back and forth is working. So that's the thing. Once a ping is working, that means packet is coming back to you. Means that link on both sides. If you're going the other route and ping, it'll work. Right. Imperative I get this part, this part correct before proceeding, because if it's not working and a ping end, this is for a group project as well. You're gonna have not gonna work out, right? So we're gonna open some checks. I might do some checks. I could do some. Open the consoles from ping the IP address for each directly connected neighboring router, and show, which is what I just did. One of them being configured with the right IP addresses, right? If these are misconfigured, use the no IP and remove it if it is a problem, right? And that's why I did the show IP to make sure it's meeting up what I did, and it matches with the interface. All right, so if I come back into intermediate and I did IP interface brief, this IP to interface mapping is what you want to look at in your document. It matches your document. If you're troubleshooting and you have to change it and it is different from your document, and it is that new change is what's supposed to be, fix it in the document, right? Do version history and stuff to sort it out. Right, so we end of section 1. We're good here. Now we're going into the real stuff. Creating RIP version 2 routing entries. And this is the thing. Once you do all the work in the backend with the IP addresses, this RIP part is going to be very fast and very easy. In fact, it's going to be so fast, I'm going to spend the rest of the lab doing breaking on links and testing redundancy of RIP. Right, so it's saying, hey, it's done, it's easy. Yeah, well, that's what it is. And that's what I like about dynamic routing protocols. So first things first, identify the directly connected networks on each router. Right, so we have, let's say, users. What's our directly connected? Remember, we didn't put it out in the plan, but let's go back in our sheet. What is it? There it is. Look at that. I created a network column. Right? That's a directly connected network. It's matching up, and you notice there's the same for both sides. User intermediate. But now we're looking at, okay, on users only, what are all directly connected. So we have 172.6.1.0, 172.6.2.0, and then you look at anything else in users. Oh, not here. Where is it? There it is. 192.168.10.0, 192.168.20.0. Now you ask yourself, look at where I have to go and find this information while I was building out my configuration, right? Would it be easier if I had this on a simple table, right? That is what this table I did here. I have the diagram, and now I did this. I didn't do it in a table like this. Ideally, it would have been great if I did it. So I did not put it in where I created a whole table just to say all the networks on each interface node. You'll have to build that out based on your planning, right? Maybe in the next revision I might do that, but right now you have this information at least here, right? So this is part of your planning process. And that is what I expect you in a group project as well. I need to see you guys create a table of all the devices and the networks that are on the devices, because why? It's going to be helping you with your configuration in your dynamic routing protocols. Because once you know this, it's easy to tell RIP, hey, these are the networks to send. Tell EIGRP, same thing. They're all going to have similar commands, right? Just variation is slightly different, but the more or less the network is going to remain the same. And you can do it all. Right, so we identify these networks. We already know. We set them up. These are these guys. And you'll notice a few things. There's some duplicates here. Look at this guy, he's duplicating. 3 zeros duplicating here. That's fine because it means 01 and 02 is going to be linking up. Users would have a duplicate with IT because users is way on the other side. So you'll have a duplicate with users and an intermediate, right? So let's do a star here. And you can see a star here. And then a 2-0. Who's a 2-0? Well, let's see any 2 zeros. Yes, look at here. Intermediate 0, 2. I could do a 1. Let's do a 1 here. And a 1 here. So you're going to get duplicates in some. You're not going to get in others. Right? You notice the overlap. There's some overlapping here and there's none overlapping. This is going to help with the routing protocol, because once you get an overlap somewhere in terms of one device knows the other network, it's going to create a path. It's going to learn that. Say, hey, look, I can get to here because I know 2 networks. Jump for one, go to the next. Right, hold on. So let's go back. Right. Oops. Keyboard is. Right. Okay. So we kind of covered all the routers, 1, 2, 3, 4 of them, and we did all the we know the networks, right? So now we're going to configure RIPv2 for all relevant networks interfaces. It's simple. You guys could do it easy without even following and the network commands. So that's why it's going to be easy. So we're going to start with users. Look at that. This protocol went up. We haven't touched them until now. All right. Enable configure terminal, right? Repeat interface brief. Just not do. I'll just do a 2 show because we're there, right? These are the IPs matching up to the necessary networks, right? So now router. So I'm going to do router question mark, and it's going to be different protocols here. In this course, we're going to do RIP, OSPF, EIGRP. In the one course, we're doing BGP. So literally, these 2 courses, you're going to cover all the 4 routing protocols are here, the main ones in packet tracer. Right? So that's what it is. So we have router, oops, RIP, question mark at the end. There's nothing else in here, so we just press enter. It's getting into the router configuration mode. If I do a question mark here, it's going to give me a whole lot of stuff. Let's see what we're going to do. Most likely we'll do it with auto summary. We're going to deal with default information. We're not touching distance so much. Network is going to be done here. We're going to do no if we want to remove an entry. Passive interface, we're going to touch this. We're going to do redistribute in terms of your group project and stuff. Not much on timers. We're going to do version. So you realize it's over almost 80%. 3/4 of all these commands we're actually using this, right? So we're going to look at version. And we're going to use version 2. And not version 1. Version 1 is using the classful, which is the ABC classes, and that could cause trouble with learning routes. Version 2 is allowing us to use classless, means it's going to use class. Yes, we're going to show the class network when we check it out, but it's going to use the interface IP mask combination to help know that, hey, this network, even though it's a class B network, like the 172s, which I did, the other interface, which has another 172.16 IP, it's two different networks, right? So that's where the classless is using the mask. Version 2 is going to help with that. No auto summary is the next component, right? Which is something called auto summarization. And this is really critical with RIP. If you allow auto summarization, it's going to say, hey, all my 172.16 networks, it's learned through this direction, and it's not going to cater for all the other separate sub-networks that we have done, the 255.255.0. So you're going to assume everybody is 255.255 and then collapse that information is going to be sent, and the update is going to be sent out to everybody and say, okay, to get to me 255.255.00, this one has it. Or everybody's going to say, hey, get to all these, and is going to go to the other routers. So everybody's going to advertise to get to this. You could get to this class B network, come to me, which could be a problem because you're going to, remember we subnetted our 172.16. You don't know where to go for which one. And that's the problem. So that's with the auto summary problem. So that's why we do a no auto summary or auto summarization of routes. So we're not going to do that. Take it out. So this here is the most important in RIP, as when you're checking it, even in any when we use stuff, the exams and stuff, final exam, this was what you need to do. Right? That's it. Classless. Let me just turn that. Mask. Using mask. Means it's using mask. Right. For this, we're going to use network. Network command, and then we're going to just put in the network, right? 172.168.1.0. Let's do a space question mark. Nothing else here. That's how RIP is. In the other router protocols, we'll have to put masks and what we call wildcard masks and stuff. So this is the first network command. 16.2.0. Now, this is the thing. I am putting all the network commands here. In RIP, because of how it works with classful stuff, it uses classful A, B, and C. The 172.16 is a class B. I only need to enter it once. 172.16.00 network. And it'll, quote unquote, because of the no auto summary and all those things. And RIP version 2 is going to use the 72.16.1 and 72.16.2 networks and actually put it in the routing table. And I will show that when I do the show running config. We'll see why. Right, so even though I entered the 2, the reason why I'm doing this is for your planning. When we start to do the dynamic routing protocols such as EIGRP and OSPF, you need to put all those networks in there. RIP you don't have to, but the others you have to. Now, I'm making you get that bad practice now so that you're going to use it later, so you wouldn't confuse yourself later on and say, oh, you only did it for RIP. You forgot to do it for the others, and vice versa, right? You did it for the others, but you didn't do it for the RIP. So that's where the problem is. You don't right? You don't want to actually miss out networks in the more advanced dynamic routing protocols. 8.10.0 and a 20.0. Right? You notice all these are already directly connected, and that's what we're doing. Next step is passive interface default. Now, this is the thing. this prevents, and we're doing it. This is even the Cisco packet tracer, like the exams and stuff, and even the course, they will, well, they stopped doing Europe in the CCNA exam, but you're still going to have to do it for the others, like OSPF. Passive interface default prevents updates being sent across all interfaces, right? But we want to make sure that the updates are being sent between the routers. We don't want, so let me just come back here. Right, we're going to select all interfaces passive so the updates are not going to be sent across to the other routers. And the question is why? Because you don't want a PC or on a Wireshark to pick up routing updates. Because now it's going to pick up updates that could happen from across the network. And your PC is going to say, Wireshark can say, hey, look at that. Now I know about other routers on this network. Right? And that's a security thing, or cyber security as well. So that's why we want to set this up. That's a part of security equipment. What we want to do is do a no passive and set no passive to the directly connected interfaces with other routers, right? So in this case, gig ethernet 0/0, and to do a no passive, gig ethernet 0/0/0, right? And these are directly connected to the other two routers. So that's the intermediate 0/1, intermediate 0/2. Move the mouse over 0/0 and 0/1, 0/0/0, sorry. We don't want the PCs to get these updates. You'll notice that, so that's 1. 2, you'll notice I'll do it on all the other routers, even though they're not connected to any PCs. Why? Because there are other interfaces. Let me mouse over 1. We can see, look, well, the VLAN 1 right now, but you have other routers. Look at this guy. He has a lot of serial links, and they're down. But if we do a passive interface, don't put a passive interface default, should ever these interfaces be connected, permanent, routing updates will be sent across those links. So that's why we do a passive interface default to make sure everything is locked down, and then do a no passive on those specific guys, right? Now, sometimes the packet tracer exam, if you are doing a lab exam, sometimes it's telling you, no, we don't want that. We want to do passive interface for each interface listed. TDS, look at this. There's about 6 or 8 of them here. 9 interfaces here. And they want you to do 9 commands to interface default and no passive in one of them, right? So it depends on the Cisco package and we have to do it, but you know it's an option to do it. Default is the shortcut way. In the case a new interface comes up, somebody decides to plug in one or add in a new line card, it'll set the default one time. So it's secure and everything. So that's the reason why you would do default. Right, so we did a no passive, and then we could do an end and do a show IP rip database. So you could use these commands. Right, there it is. It's showing this what is going to be in the database is going to send out. Now remember, we're not sending any updates as yet to other devices. So this is the only thing in its own database. It didn't learn anything else, so it won't have anything else. We could do a show for protocols. Oh, come on. Sorry, IP protocols. It's IP protocols RIP. That's supposed to be. Right. It's going to show you all the dynamic routing protocol running on this system. Now, for the group project, guys, you're going to see us happening with when we're doing this, and you do show IP protocols, you can do it for all your multiple protocols running. So those are doing what you call it, the redistributed routes or redistributing OSPF and stuff. And you do that on one router as a border router, quote unquote border between different routing protocols. And you do show IP protocol, it's going to show all of them. So what you could do is show IP protocols, and you're supposed to be supposed to do it, but this one not allowing it. You can actually show IP protocol and you go specify RIP or EIGRP or OSPF. Right, so show IP protocol, let's go back again. Send updates every 30 seconds. The default, all these things is what you will look at when this exam might come and ask these things. Redistribute and RIP. That's fine, we didn't touch that. These are the interfaces that are sending information on. It's doing automatic summarization. Remember we entered the two 7C16 commands? Look at that, it only entered one entry here. The other two are separate. Look at that, passive interfaces, while these are not passive. Right, and there's this distance, default distance is 120, that's the administrative distance, right? We can change this, but that's Cisco's default. Huawei has their default as well. And the exams will ask for those. Right, and then show IP route. Nothing new here. Why nothing new? Because RIP is not learning anything else to add onto this table. It can send updates, but it's not picking up from everybody else. So that's why this table is only showing only directly connected, which we did. When we set up another router and that information goes across, then you're going to see the magic. Right, so now we're going to do the IT RIP2, which is interesting because it's on the other side of the network. So right now users are sending updates on these two links, but these intermediate 1 and 2 is not seeing it. They are not seeing anything. They're not doing anything. IT is on the other side. Remember I tell you, these updates are more like broadcasts. So routers stop the broadcasts, right? So the updates are not going to go through router 2 to IT. It's going to stop right there. If there's a switch here, yes, it'll go through. So updates, route RIP updates, OSP updates, all these are broadcast updates. In IPv6 style, they have it. Though the IPv6 versions use multicast. So these updates are not going to go to IT, but either way, we're just going to configure IT and let IT have the configure RIP on IT, right? So you notice some things repeated. Router RIP version 2 not a summary. Version 2, no auto 1, no auto summary, right? So we're not going to continue with it. Next slide. And we already learned what the IT network, that's where we pre-planned it, right? We're already in RIP config, we're going to do network 172.1, 6.4.0, 5.0, 168.30.0, and you'll notice I do this one as well. I put the ISP IP as well, 181.188.81.0. Now, in most cases, you don't need to do this. I did it to let other clients know about this ISP network. But in real world, you don't configure it. What you do, you set this IT as it has some default gateways going out, and we'll set that. But what we're going to do, what we should have done was do not tell it to advertise this network, the ISP network. But that's okay. Just to let you know, at this point, because we did not set passive interface, the moment you start to enter these commands, right? The moment you start to enter these commands, routing updates are going to be sent out on all interfaces that are active, that are upstate. All right. So what we could have done was do a passive interface default first, and then set the network, right? If you want to be really secure and not allow updates from going out. Passive interface, oops. We could set it or default, and then we could do a no passive. And this is the thing, it's only a no passive on 2 interfaces, right? Between the intermediate 0, 1, and 2. Another 0 there, right? Database is only going to contain its own, what we're telling it to network to advertise, right? It's 4, 5, 51, it is 188 and then 50, right? So that's what it's put up here. Traffic protocols, give you more details. Route, what it is non-passive, where its updates are sending on, what's not updates sending on. We also see the route, not what networks. Again, 172.16 is truncating it. And that's why I did 172.16, a class B, to show how RIP deals with it. You can even do a class C. but B is enough. And who's it learning from? Nobody else, right? So it's not going to populate its table with RIP entries. It's going to only show directly connected. So we haven't reached there yet. I want to do something here, just deviate. I want to show you what your command is in the RIP. Look at here. In your running config, this is the command we use, router RIP version 2. You can actually copy this and paste it back in your CLI. So you can actually create your command file. As a matter of fact, I do have a command file with all of this. It's already on my learning, so you guys could pull that down. Right, so you can pull this down and actually see what it is to do. So you notice I entered 2 networks, but it summarized, it did its own summary, right? And then it actually entered these 2 because it's summarized based on the class flow, right? This is a class B, class C, class C. So each class C, because of how the subnets are set up. If it was a 188, 181, 188.10 or something, I would have just put this alone. Actually, no, sorry, this is a class B. Look at the zeros here. Right, we did a 31. There's no 31 here, but it's a 0. So it's a class B. The only reason why it's different from why it didn't match with SEM2 because it's all up to each first 2 octets have to be the same for it to do that. If it's not the same, it's over 2 different networks, right? Now, why am I adding all the 2 entries here? Because when we go into the other routing protocols, we'll need it. So that's why you plan ahead with all the networks. Help you out in the long run with troubleshooting. Right, now the intermediate 01. So what's happening here? Updates are supposed to be going between users and this link. Intermediate 01 is seeing updates via broadcast, but it's not able to do anything with it, not listening for it. Same with IT. IT is sending updates here and here, but these 2 guys are not picking up the updates. They're seeing it, but they're not processing it. So now we have to tell them, hey, we're seeing updates, use them, right? So intermediate 01. Same as before, and we set the network. So you see how easy it is. Router RIP version 2. No auto summary. Come on. Sometimes it does, right? Network command 172.1.6.1.0. All right, so we missed that 1.0. We missed the last one, right? There it is. All right, look at that. I did a network command and I did it wrong. I spelled it wrong, right? Let's fix this. No network. Let's remove it. We don't want this added on the equipment to make it erroneous, right? Same for your group project, guys. Don't just randomly start adding networks, right? I really hope you're doing that. I'm not going to penalize you for it, but I really hope you don't add on unnecessary networks in here. All right, so let's fix this. 1 0. All right, 3 0 and 4 0. Now, technically at this point, once we start setting networks, routing updates are going to send out. It's going to learn it. It's learning right now. So right now it's learning. If I do a show IP route, it's going to show you RIP entries, but we'll reach there. So I'm going to do passive interface default. Lock it down. So now we're going to lose routing updates. We'll do that later. Now we're going to do no passive. Where are these interfaces here? 0 0, 0 1, and 0 2, right? Stuff 1, 0 0, 0 2. Doesn't matter which order, right? And try to databases, right? So something's a little different now. We're getting entries here now. These are networks it's learning. It's learning these networks. Remember, we did not put the 181. Look at that. Learned one. Look at this. the database is being built up with updates from other routers. This is where the magic starts to happen, right? Show IP protocols. Do you notice this protocol same as before? 3 interfaces. It's routing networks. Look at that. It's only routing for one network. All is 172s, right? Even though we added 3 entries, it collapsed it because it's a class B. And this is where it's picking up. Look, route information sources now is adding. It's learning this from 2 other devices. All right, so that's why you're using this. And then show IP route. And there it is. Directly connected. And look what's happening. There's additional entries happening here. RIP is learning now. And you can see when you go to the ledger and you're seeing R is RIP. So these are being learned. Right? These are being learned from the others. From the other 2 routers. So information is being sent across. And like I said, only needs the routing table. Once it's entered here, then it's actually going to be used. If it's not there, it's just wasting processing time and stuff, and it's going to be worthless. Right? So you don't, when you configure, make sure it gets into your routing table. Right? So we did intermediate 01. Technically, the routing is working, and we could test it, but let's finish out immediate 02. And then we could start doing some load balancing and redundancy testing. All right, not summary. All 172s, right? Because it is, I could have just entered 172.16 and 00 and it would work, right? But I'm doing this because I want to make sure I have this information done correctly for other routing protocols. Plus, you'll know that you're doing the right thing here, having these guys set up, right? Right, 000, 010, and then 00. Right, now this got more. Learned what happened is learning multiple networks around same network through different paths. Sorry, that's how it's working. So you're going to see some multiple networks learning, and it's going to see multiple entries. Is it here? I see. Let me just check it again. Right, I'm not showing it. We'll have to check it on another place. Right. Show IP protocols again. RIP routing for the networks. And then show. I'm not seeing. Right, as they are. Yeah, why did it happen? Broke out, look at it, completed properly. So, show IP protocols. Not only showing you passive, but it's also showing you which other routers it's communicating with, or making setting up a neighbor adjacency. And then show IP route, right? So it's learning what? More of these routes. Look at this happening. It's learning the same network. It's learning through 2 different interfaces. It's going through 2 different routers to get to the same network. RIP is doing this automatically. Imagine you have to set all this statically. And what happens when you bring a link goes down? This is how to change it statically, right? So that's why RIP, the dynamic routing protocols do a good job. Right? So now we're going to do connecting to the internet. We're going to do some static routing, what we call redistributed default gateway we're going to set, port 0, and then we're going to tell the other routers to use that static route going out, right? So what we're going to do, we're going to identify the router as going to the internet, typically the only other router going to the internet, right? So in this case, that's the only one you need. So the only one going to the internet is IT. Now, in the case of other places, let's say UE, for instance, we have more than one router going to the internet. So we can actually have two static routes, one on each of those guys going out to the internet. And the process is going to tell the other routers inside, hey, to get to the internet, you can go through this router or this other router, right? And that's the thing about it with redundant links. We didn't have that set up. I don't think that setup is in, I think it's in one of your group projects. You guys are going to do participate redundancy protocols and stuff, and you're going to have two redundant links going out. Now, that's the thing. It's not two redundant links, it's two routers in our redundant manner providing one gateway IP, right? Which is different from having two separate routers where you have both two gateway IPs to work with, right? That's two different sets of redundancy. And you can't have a mix and match of that. So who is this? It's going to be IT. So IT router is the one you're going to set up some default gateway stuff, right? So you set a default route, only static entry used in this whole lab, and it advertises default route via RIP version 2. And that will come for the exam, Cisco exam in the OSPF stuff. Same thing. So let's get this stuff configured. Enable. Show IP interface brief. Main reason that I'm doing that is just to show you who is connected to the IT, 8166, right? And the gateway is supposed to be 8165. What we can do, let's do a quick check here. Is it the right one? If it's point to point, we're supposed to be able to ping the IP on the other side. Normally it's one IP more, one IP less, depending. We start with that. If it doesn't work, then you have to do a IP scan. Right, so it's pinging on the other side. Good. Configure terminal. Remember we did IP route before, right? Port 0, 1, 2, 3, 4. Tell everybody, hey, you know what? You're going to go to the ISP router, right? Right, make sure that's done correct, right? If it's not working, it's gonna have a problem. Right. So now we're going to router RIP, and then we're going to tell it the default information originate. This is to be done on the router with the default gateway. You don't have to do it more than once, right? Right, we do an end, and we're back out here. Right, so before we do anything, I didn't have me do any other show commands, but let's see how it's going here. Right, so show IP route. This is our static route here, which is okay. And let's check what happens with the other guys. Let's say intermediate, let's do users. Right. And what's happening here, look at this. We have our star. Star is kind of the default. That's what it is. It's nothing new. And it's saying that to get to the default gateway going out to the internet, or in this case, will be to the internet, it's going through two other routers, intermediate routers. So it learned two routes to get to this default, which is cool. Right, so now can we access the website? Using the ping performer diagnostics, so we can start pinging. So from a PC, and let's pick a PC all the way down here. All right, we're going to pick the IP diagnostics work, right? 64.2.8.139.231. And let's see what happens. Right. I'm going to use packet tracer simulation mode to see where anywhere this is. Simulation mode. We have the filters. ICMP is filtered. We run it, and let's see what happens. Going across. Users. Look at it. Intermediate. It's going across, doing what we need to do. IT. Outer ISP. And it's a server down there. It's getting here, right? There it is. Coming back and returning. Look at what's happening here. You notice the packet is coming back on another link. It's not coming back to intermediate 01. It's coming back on intermediate 02 and to users. If I repeat the ping, it's going back intermediate 02 and the return may come back to intermediate 01. Right? So this is where hop count comes in. Right? So because the hops getting to this place is the same distance, hop count is this distance, the same, right? The hop count is saying that the parts are the same, then therefore there's both are equal cost, means that the packet going through either one will take the same time, and that's fine. Cool thing about it is that you can have bandwidth going one direction and a return bandwidth coming through the other direction, and you can actually increase capacity that way. Right? So let's go back to real time. And yeah, that's how it's happening here. It's working. Right? A little question coming up here. So return packet. How does the ISP router know where to send the return packet? Right? A little question happening there. Why? Because this little cheat I did here. I told the ISP I have to do some stuff, right? You notice some things we didn't do, right? We never touched ISP. So IP, let's do something here. How did ISP know? I have set some static routes in here. I did some cheating, right? I told it, hey, 170.16, go back to IT. 181, go to IT. So look at this. These two networks, not really 181, but more than 172. So there it is. To get back to the other networks, go to IT. Right? So, but because it's private, so I don't care how you use this. So end-to-end in terms of if you use a network address translation, I think this wouldn't work. To get to the 192.160 network, look what I did. I did not even do a class C. I actually do an auto sum. I actually built a supernet, a /16, and that's where VLSM comes in, or so we call a summarization of routes, or even supernetting. I took all the class C 192.168 private class C networks and made it into one supernet /16. So I don't have to put all these entries there. So I can add in another 192.168.50 or 100, and it will be able to route back. So you have to understand start routing, no masks, so in order to set back this stuff. And that's how it knows to send it back, right? Right, so can we access 888 at this point? Who's on 8888? Well, we know that's Google DNS. So let's try pinging it from PC0. Right, I said request timeout, and it's supposed to get a reply, right? Which means DNS, technical DNS is working. And as a key, and how does the ISP know where to send a return packet from? We worked it out, right? So 51. So now can we access this website? We could ping it by name. Right? And it's going to resolve it with DNS, and you get a reply, right? And therefore, you can use your browser by a web browser, right? So if you can ping the name is resolving, so ping is ICMP. I'm going to go another PC. Let's do PC1, or even PC2 for that. So 3. Right, now we're going to see if another did it crash? It didn't crash. Okay, save packet tracer before I break anything. Let's go back again. Right, okay. Right, there we go. We can actually get access to it. Right? Right, we can get access to the website. HTTP, not just because of ICMP, but HTTP is working too. Right, see what packet is going, we don't need to do that. Now we can access both the website, and DNS is working, right? So we could check the routes on each router, and we could run all these commands. Do we have repeated? Right, so that's the end of section 2. So let's go to each route, just some of them, check them out. Right, look at this. This one learned the default, and you only have one entry. Why? Because there's only one IT, right? Only one direction to get to IT. Now, technically, I could break a link, and it could end up going to intermediate 02. Routing up, table change. Look at that. Added default wasn't there. Now it's there now. There it is. All right. So it's dynamically changing. So we could do the RIP database. Right, and then track RIP database. There it is. It learned where the default gateway is, and it know where to go to. Right, that's through the IT. Right, so it started IT. The database is growing as you add more. Right, so we end of section 2. Right, so essentially we've done everything here. Now we're going to test out RIP version 2 resiliency. Right, so what's the purpose of it? Yeah, it's easy to set up, which we just did. Look how easy it was. You didn't have to do all them static routes. So that's the reason why the group project is so large, because it's once you get the idea of how to put it together, it's easy to then implement, right? And especially with how the whole thing with GNS, 3 large pixel for your screen, for your window, larger, you can get everything in one view, zoom out, right? So the next question is what happens when the link goes down? Let's check that out. So we're going to break the links along the route, and then we're going to see what happens when we identify a link that's broken. So we're going to go and test it out when we go into simulation mode. So we're going to do a continuous ping. And we could do the 1,000 pings. All right, so let's not see, it's an N. All right, so it's a continuous ping. That's okay. So now we're going to identify a link in the backbone, right? So when we look at backbone, this scenario, we're looking at all the backend routers, these guys in here. So right now the packet is flowing and it's going back and forth, right? It's picking between these two routers to actually go across. So what we're going to do, we're going to break a link. So right now it's using all these links. We can actually take one of these guys and shut it down. So let's do, so we're going to see simulation mode. Let's get into there first. I'm going to do that because I'm going to see what happens, right? Simulation. So stepping through, right? And it's coming back, right? Going through the next link, come back in, right? Perfect. So now we're going to break a link, intermediate 01. I'm going to go physical, config here. Who this? It's gigabit. Gig 00, right? We're going to go on intermediate, break a link, gig 00, say, hey, it's off, right? shut it down, link went bad, etc., etc. That's all the reasons, right? And then we're going to check packet tracer simulation mode and see what happens, right? We're going to step through now. Right, so the link is going through one direction. Remember, there's a return. So where's this return coming? All right, return is coming back. And next what's happening? Your packet is going through good. No problems. Now, if it was coming back a different part, it might have give a timeout, right? But RIP learned it and did a good job. So we're going back real time. That's why I'm doing a large count here, right? And we broke a link. Look at this. We had a high delay here, latency here. That's when the link was broken, most likely, right? We did a few pops. So there was some happening here. The packet took a bit to learn, but I didn't lose a packet. The cool thing about resiliency in a network, if it comes down, if you only get one ping timeout, and that happens with our backend systems, our enterprise systems, we can move systems back and forth to different sites, and you might only get one ping timeout. That's more. Just go. Doesn't matter. Just click a link. The rest of it, click a link, tell it to browse, and it's. So look at that. Right, breaking more links. What are the links we could take down, right? So you look at your design and you're seeing, hey, packet is flowing here. So let's break another link. So we're seeing intermediate 2 to IT. Let's go on intermediate 2 and let's break a link here. Let's go simulation first. Right. So we come in here, config, and who it is, we're going to break the link to IT, right? Gig 010. That's this guy here. Have IP set, everything, cool, we're going to shut them down. Link is down. Now, technically, you ask yourself, hey, is there a partner? Visually, you're going to see one, right? It's supposed to go and use this Z-shaped part to get out, because there is at least one going out. So let's see how it was. Right, so going to step through. Remember, we're in a simulation mode, so we're going to see. Packet is going through. Packet is going through. All right, so we got to bounce back. Right? Let's see what the PC is saying. Destination host unreachable. Okay, what are we going to do? Bounce back. What's been happening here? What's happening? Oh, that's not good. Uh-oh, there we go. Let me go back. Back. There it is. I could go back on next view, right? One, two, three, 4, 5, 6 destination hosts unreachable. All right, that's what I like about packet tracer. You're supposed to get the 7th. 1, 2, 3, 4, 5, 6. All right, it's supposed to have 7 destination hosts unreachable. Let's take a look. 5, 6. Okay, still 6. That's fine. All right, this time the packet was able to go through this route and get back out. Now, is it going to come back in? Let's find out. Yes, it's taking back the part in here. There it is. We got back our response. So you'll notice one thing we had to, so even with this level of resiliency we had, the route went down. Why? Because RIP did not really keep it on its active table. Say, hey, that's the backup link because of the next hops, right? It said, hey, you know what? It went down. I have to now relearn something. So I come to users. So let's go into real-time mode because I need to get things working here. Right. So now I do a show IP route. the users should have ended up having learn two RIPs to get to certain things. Now there's only one. Let me see if I had it before. Yeah, look at that. I used to have 2 routes to get out to the internet. Now I only have 1 because I broke down a link, but I can still have access to the internet. All right. Try the access to the internet again. Did it work? Yes. But we had to do some multiple things. Times out happening. Don't need to reconfigure anything. This is the power of dynamic routing. And this is a basic dynamic routing protocol. So yeah, right? So that's what we have, and that's demonstrating this. So what other links can be taken down? We could try disabling it, and this is that point. You're going to repeat all critical links in the backbone can be disabled. So I'm going to go through that. I'm more or less wrapping up here and say, hey, you know, I can actually, what other links I can take down? Well, technically, if I take down any other links, because I took down all the critical ones, so this is what you could say critical part. So if I take down any other link, that's it. The access to the internet is going to be broken, and then they wouldn't have access, right? So then you have that break. So I'm not going to demonstrate that. Guys, you can check that on your own. And this is the end of section 3. So we're done here. Right? Of course, you save your router configurations for users. This is what I expect you guys to be doing for the group project as well. And yeah, just run through this, save. I'm just putting the commands here. This end of section 4. This optional securing equipment, where you add the line configuration, all these things. You don't have to do this, but it's be good to know where you could password equipment and stuff like that. Please try not to do that for your group project because you're going to have problems getting access to the equipment. You're not required for the group project, right? That will say it's optional. Right? And this is the end of lab. All right, everybody. Thank you very much for being here. And I think I'll post it up just now. Have a great weekend. I'll see you guys on Monday. I'll see you guys on Thursday. And we'll have our coursework exam on Saturday. And during the course of this week, I'll be announcing out when the lab exam date itself will be 2 weeks from now. 2 weeks Saturday from now. All right, so I'll see you guys on Monday. Bye, everybody.